All right, welcome back, everyone, for another deep dive.
This time we are getting into something that you use every single day,
Probably multiple times every minute.
without even thinking about it.
Yeah.
It's your reaction time.
Have you ever thought about why?
Sometimes you can, snap your fingers and react instantly,
Yeah.
and then other times it's
Oh, I need like a few seconds for my brain to catch up to
yeah.
what just happened.
Yeah.
We've got a fascinating study for you today from 1953.
That delves into the science behind those split-second decisions that we're making all the time.
And as you'll learn, the amount of information that you're dealing with at any given time,
Directly impacts.
how quickly you can react.
That's right.
So we're going to unpack all of that today. And plus, we've got some other cool insights.
About how our brains handle information overload.
Yeah, I mean, it's pretty remarkable because this study
Which was done by Ray Hyman.
was published back in 1953 in the Journal of Experimental Psychology.
Wow.
And it was really inspired by communication theory.
Which kind of lays the foundation for how we think about the amount of information that a message contains.
And so if you think about,
A really simple question,
Yeah.
yes or no.
right,
It's a pretty easy...
one bit of information, one or the other.
Right.
If I ask you a multiple choice question with 8 different options,
It's going to take you a little bit longer to sort through that, right?
it's like, yeah.
8 different restaurant menus.
Exactly.
And trying to pick one.
Yeah, exactly.
Everybody wants something different.
Too many possibilities.
So Hyman really took that insight.
And applied it to our reaction time.
Yeah.
Some more choices,
More information to sift through.
slower reaction
More information.
equals slower reaction time.
Exactly.
So that was like his main hypothesis going into this.
Yeah, he had 2 main hypotheses.
One was just what you said,
Mm.
that as the amount of information you need to process increases.
Reaction time would also increase.
And then the second hypothesis was that,
This would hold true regardless of how the information was changed.
so whether you're talking about colors or sounds.
Or, different sequences of events or whatever it is, the more possibilities there are, the slower your response is going to be.
Interesting. So if you had more,
Colors or sounds.
it's going to take longer to react than if you only have 2 colors or 2 sounds?
That's exactly right.
Okay.
That's the hypothesis.
Okay, so how did he actually test this out?
Well,
I assume it was...
a little bit more involved than just giving people trivia questions or something.
It was.
Yeah, a little more involved.
He had 4 male college students,
Oh, wow.
a small sample size.
But they each had
15,000 reaction times recorded.
15,000
Oh my goodness.
using voice keys.
Wow.
So you can imagine they're sitting there and they're saying now as fast as they can when they see a light
Oh, wow.
or they hear a sound or something,
So they're just like staring at this thing.
waiting for it to change
And then as soon as it changes, they have to say now.
as fast as they can. Yeah.
Oh my goodness.
And so to do this, he designed 3 different experiments or
First,
sub-experiments, really.
okay, so it's like we've got level 1, level 2, level 3
That's a good way to think about it.
of this brain training game.
Yeah.
And they're going to get progressively harder.
Yeah. So the first experiment
He basically changed the number of equally likely choices.
that the participants had to respond to.
Okay.
So
We're all familiar with the red light, green light kind
Yeah.
of test.
imagine instead of just 2 lights, you have 4 lights or 6 or 8 lights.
Oh, okay.
And they could be any color.
So it's not just red or green. It could be.
Red, green, blue, yellow.
Exactly.
And so the idea is the more buttons,
The more information.
the slower the reaction time.
Okay, so that kind of makes sense intuitively.
Right. If you got more things to keep track of, it's going to...
Take longer to figure out which one to choose.
Right.
Okay, what about experiment 2?
Experiment 2.
What did he do to mix things up there?
He kept the same number of buttons, but he changed the frequency with which they lit up.
Okay,
So
imagine you're taking this test.
And you know that 90% of the time the red button lights up.
Oh, okay.
You're going to be primed and ready to press that red button.
Mm-hmm.
But if he made that,
Unpredictable? Or if he made it so that there was no pattern.
now your brain has to work a little harder every single time to figure out what's coming next.
So he was throwing curveballs in there
Exactly.
to see, okay,
How adaptable.
is the human brain
Yeah.
to these changing patterns.
Yep. And then to make it even a little more complex.
He added in the element of sequences.
Oh, okay.
So in experiment 3.
For example, he might do something like if the last button was red,
Okay.
the next one is more likely to be green.
Oh.
So now we're getting into...
kind of like those pattern recognition games?
Yeah,
Or
where you
not-
got to figure out the next shape in the sequence.
That's like a little memory game as well.
Exactly.
Yeah. He's really testing how well our brains can predict what's coming based on what just happened.
So all three of
They're
these.
about reaction time.
Yeah.
They have these different variables to them.
Yeah, he manipulated the information.
In a lot of different ways.
Okay, well, now I'm curious.
How do you, measure?
How much information is in each scenario?
That's a great question. And this is...
I think it gets really cool.
So he used a formula.
Developed by Claude Shannon, who is considered to be the father of information theory.
Oh, wow.
And so it's like he was treating...
the human brain as a communication channel.
With like a limited bandwidth.
Okay, so if you have...
network cable.
Right.
Yeah.
And you're trying to send a lot of data through it.
It's going to slow down.
Exactly.
If you're trying to send just a little bit of data.
It can go really fast.
Yeah. So this formula allowed him to actually calculate
how much information each task required.
Which is kind of mind-blowing.
It is kind of mind-blowing.
When you think about it.
That he could actually quantify that.
Right.
Okay, so what did he find?
Oh.
Did those college students...
But their brains actually act.
Like little well-behaved communication channels.
In a nutshell, they did.
So just as he predicted...
more information led to slower reaction times.
Okay.
This was especially clear in Experiment 1 and 2.
Okay.
Experiment 3 with the sequences.
It followed the pattern.
But it wasn't quite as strong.
Okay.
But the most amazing thing is that when he combined all of the data...
the relationship between reaction time and the amount of information.
explained between 88.8 and 97%
Wow.
of the variation in their response speeds.
That's a huge amount.
That's a huge correlation.
Yeah, it's like almost a perfect correlation.
It is, yeah.
So even back then, they were...
finding evidence that our brains process information.
in a very predictable way, kind of like a computer.
Right.
Like a communication channel.
Yeah, and I think this has...
Big implications for...
how we design things.
Yeah.
So if you think about...
websites, apps.
Yeah. Airplane cockpits.
Yeah.
All of these things.
Need to be designed in a way that doesn't overload people.
Right.
With too much information.
Because if we have...
too much information?
our brains are going to freeze up.
They are. And it's like...
trying to drink from a fire hose.
Yeah.
You just end up soaked and overwhelmed.
Totally.
Like when I'm trying to book a flight.
And there are 50 million options and pop-up ads.
My brain just shuts down.
Yeah.
So,
apart from this central finding.
were there any other surprises in this study?
Yeah, there were actually a few pretty cool things.
One was that
Certain combinations of conditions in the experiment.
produced unexpected results.
Okay.
The effects weren't always simple and additive.
Sometimes things got a little weird.
Okay.
Which is really cool.
Because it suggests that our brains are even more complex
And we even realize.
than we give them credit for.
Yeah.
Yeah.
The other thing that he found was that
The students got really, really fast.
at reacting to stimuli, that appeared repeatedly in a sequence.
Okay.
So even during these,
Relatively simple tasks.
our brains are constantly learning and adapting.
It's yeah.
You don't even think about it.
But your brain is
You're
constantly...
trying to figure out patterns
yeah.
and optimize.
Speed.
Exactly.
Wow.
And then,
One other really cool thing
okay,
was that
when he plotted the distribution,
of the reaction time.
it wasn't a smooth bell curve
Oh, okay.
like you might expect.
Instead, it was these multiple peaks.
Okay.
Almost like these mini waves.
Okay.
And so this suggests
That maybe our brains have
these natural rhythms or cycles,
an effect.
how quickly we process information.
Interesting.
Yeah, so it's our brains have this natural tempo,
Okay.
and sometimes we're in sync, and sometimes we're a little offbeat.
Okay, so out of all this,
What's the one thing?
you really want the listener to take away from this.
Well,
The biggest takeaway is that information processing,
takes time, and it's predictable. So it's not random.
there's a certain level of order and efficiency to how our brains work.
But there are limits.
Yeah, there are limits
we can handle
to how much we can handle.
at once.
Yeah.
It's like you were saying with the fire hose.
Yeah,
If you open that thing up,
all the way.
you're just going to get blasted in the face.
And not actually drink any water.
Exactly.
Yeah.
So I think that's a great reminder to be mindful
Of how much information we're juggling.
at any given time.
Right. Right now I've got...
10 tabs open on my computer.
I'm trying to listen to music.
I'm trying to talk to you.
I'm looking at my phone.
Right? It's
Why am I doing all this at the same time?
it makes you wonder.
It makes you wonder, doesn't it?
It does.
Maybe we're not as good
At multitasking.
as we think we are.
Exactly.
Anyway, thanks for taking the time to do this deep dive with us.
I hope you enjoyed it.
And we would love to hear your thoughts.
About this research.
Did anything resonate with you?
Is there anything that
You think maybe you could change in your day-to-day life
to kind of optimize?
and deal with information overload a little better?
We'd love to hear your thoughts, so feel free to leave a comment.
And until next time, happy processing.